All right, here is my video for slide 4 or problem 5-140 on our chapter 5 closure lesson. Now, I put this problem in here as kind of a refresher from triangle similarity, but in part B, we also include some stuff here from chapter 5. So we'll start with this triangle similarity, and talk about what condition are these triangles similar if they are similar. So the first thing I notice in this diagram is that it's really two triangles formed by these intersecting lines and these parallel lines on the outside. With these lines intersecting in the middle, the first thing that I can say, and it again goes back to chapter 3 when we did triangle similarity, is this vertical angle that's happening at C. Anytime two lines intersect, the angles across from them are equal. So I got this angle, which I would call ACB, is equal to angle DCE, and that would just be over that relationship from vertical angles. Okay, so there's one, so I saw that right away. And then the other thing to note to help me kind of meet one of my conditions, and I'm going to kind of take a pause here and remember what my conditions are. It's either going to be angle-angle similarity. Ooh, it kind of brings up a box there. There we go, angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Those are my similarities that I have, and we're going to try to meet one of them. Since I have no side lengths in this diagram, don't know any of the lengths, I'm going to really try to see if I can get angle-angle similarity here. That would be the only one possible if I can do it. And I already see that I have this one angle ACB equal to DCE, so that's a good start. And again, remember what angle-angle is. It just means that in both triangles, you have these two pairs of congruent angles. So I got this vertical angle. Let's go from there. The other thing to notice is that I have parallel lines here, which means DB, this line DB, is a transversal cutting parallel lines, and this line AE is a transversal cutting parallel lines. And it's hard to notice, but you could say angle E down here is congruent to angle A, because those would be alternate interior angles. Now, it's pretty hard to see. Maybe if I extend these lines a little bit, it may be easier. If I extend these, it's kind of look weird. 1 second, let me undo that one and see if I can do a better one. If I extend these lines, these parallel lines, and I'll extend this one to the best of my ability, and then I'll extend the transversal as well, we can maybe see how those are alternate interior a little bit better. I'll just extend it this way. And you can kind of see that the parallel lines are getting cut by a transversal. This is on one side of the transversal, this is on the other. And so we get that alternate interior relationship. And actually we could say that with D, or angle B and angle D as well. We actually have 3 congruent angles here. But with these angles being congruent, we are allowed to say that these triangles are similar. And they are similar. Let me write, I can't write and talk at the same time. These triangles are similar by angle-angle similarity, because they have 2 pairs of congruent angles. Okay, so that's just a recap, and I'll put them on here again. Angle ACB is equal to angle ECD, and angle A is equal to angle E, and we have that angle-angle relationship. Now, part B here, it gets a little trickier. We need to kind of remember what sides are corresponding, but first let's fill in this information. So angle B equals 80, so I'm going to put that in here. Angle B equals 80. I'm going to erase some of the other marks that we made for part A. Angle ACB, so ACB equals 29, so this angle here is 29. And AB is 14, and DE is 12. So that's the information they're giving us, and they want us to find CE, which I'm going to call X. Now, something to note here is the way that these triangles would land on top of each other if I were to rotate them accordingly. So remember, I would need to put corresponding angles on top of each other, and if I did so, I would be rotating this triangle DCE, and D would have to land on B, because those are the corresponding angles, which really means the corresponding sides on this triangle would be DC and BC. Those sides correspond, and AC and CE, those sides correspond, and then of course AB and DE correspond. And it's just going to be important to note those corresponding sides, because my goal here is going to be finding AC and then using the fact that AC corresponds to CE to end up finding that CE finally. And I'm going to call that maybe Y, because I already have X used. So I'm going to try to find y, and then I'm going to use the fact that these are similar and y and x are corresponding to find x. All right, so finding y, here's when chapter 5 material comes in. I have a non-right triangle with two angles. Across from the 21 is a side I know, across from the 80 is a side I don't know, and so I can use the law of sines here. So using the law of sines, I have the sine of 21 over 14 equals the sine of 80 divided by y, the side across from it. Cross multiplying here, I have that y times the sine of 21 equals the other cross multiplication 14 times the sine of 80. Dividing both sides by the sine of 21 to get y alone, I end up getting y equals 14 times the sine of 80 divided by the sine of 21, and I can calculate what y equals, and I'm going to do that on my calculator. 14 times the sine of 80 divided by the sine of 21, and I got that y equals 38.47. So y equals 38.47. Now, there's different ways to use that, so now I know this. And I'm going to use this to end up finding that x, because x and this 38.47, they're corresponding, like I said. And there's different ways to do that. This is the bigger triangle. ACB is bigger than DCE. And so what I think I'm going to do is I'm going to find the zoom factor. And I'm going to find the zoom factor by taking 14 dividing by 12. So I'm going to call that ZF for zoom factor. ZF equals 14 divided by 12, which gives me 1.67 if I round it. And then since I'm going from the big triangle to the little triangle, and these are corresponding sides again, I'm going to take the 38.47, divide it by my zoom factor to go to the small side, and I should have my side for CE. And so that's what the last part I'm going to do. CE equals the 38.47 divided by your zoom factor of 1.67, and I'll have my answer here. So 38.47 divided by 1.67, and I got an answer of 23.04 for my answer for x here, or for the answer of CE. So that's a very involved problem. Not only do you have to notice that AC and EC are the corresponding sides, which most people have a trouble seeing, but again, picture rotating this triangle so that D lands on B, angle D lands on B, those corresponding angles, and then it might help you see that those are in fact corresponding. And then to also notice that we need to use the law of sines to solve for that AC, which ultimately helps us get to CE by using zoom factor. Now, if we don't want to use zoom factor there, another way you could have maybe set this up would be to use equivalent ratios. In an equivalent ratio, you could have done 38 point, there's different ones you could do. This one I'm just using as an example. 38.47 divided by 14 equals x over 12. And you could have cross multiplied here and got the same x as I got, which would have again been 23.04. All right, hopefully this video helps kind of refresh you not only on triangle similarity, but again, law of sines and using zoom factor to help finding missing sides of triangles.